Good afternoon, everybody from India and this part of the world. Good morning to anybody who's joining from Europe. Um, Good evening to our Japanese, Australian friends. I'm so excited to see that we have participation from almost every time zone here because we've got registrations from across the world. This is a very interesting thing. To see that this topic is actually in the interest of so many different people from so many different regions and backgrounds. So, to start with, I would like to introduce myself. My name is Vikram Saraf, and I am the Group Director at Science and Technology Park. And I look after the innovation and entrepreneurship development at Science and Technology Park, which is located in Pune, in India. Science and Technology Park is one of the oldest and the leading technology business incubator in India. And we work with startups, SMEs, innovators, universities, R&D institutions, government bodies, private entities, businesses, um, to further the progress in terms of innovation, uh, business incubation, technology incubation, and so on. So Science and Technology Park has partnered with the International Sustainable Chemistry Collaborative Center, ISC3, which is based out of Frankfurt in Germany. We have with us Juanita and Andrea from ISC3. So ISC3 is an organization based out of Germany, established by the German Federal Ministry for Environment and the Environment Agency. And their main mandate is to promote transformation towards sustainability using sustainable chemistry based principles and the science and technology uh, that revolves around that. So in terms of chemistry applications, they are looking at applications across all industry sectors. This initiative between the two organizations to set up the International Sustainable Chemistry Club is basically to spread the awareness about innovative best practices and the knowledge that underpins sustainable chemistry, and to bring to the table the various principles and practices across industry sectors that can be looked at, explored, and discussed, and probably even applied to real life situations right now. So our effort is to bring to the table the insights shared by some of the leading experts, technocrats, business owners, innovators in the sector of sustainable chemistry, to create this kind of a discussion forum for us to put on the table some of the critical issues that we are talking about, because we all know that when we talk about sustainability, environment, and climate change, um, I think chemistry is one of the most foremost reasons for some of the key problems, and also can become the most foremost solution provider to these problems as well. So this is the fourth session under the Sustainable Chemistry Club. We have a session every month, and today we are going to focus on sustainable chemistry for manufacturing in the leather industry. As we all know, leather is one of the oldest products that mankind has had, with itself. Right from the caveman era, leather has always been with us. So it's an essential part of our life, obviously because of its versatility and its the kind of use it can be put to. So it's a phenomenal product, and obviously in recent times We've had some bad media coverage, which we want to shed some light on. Leather industry is not as bad as it has been put to
Made out.
as it has been spread out. Um, that's just one of the things. There are various different aspects in terms of sustainability in the leather industry, like resources or the use of chemicals or water, emissions, and so on. So at this point in time, we would want to focus on the manufacturing side of things and also some of the basic industrial processes that are revolving around the production of leather. So today's topic is a little interesting, and we've got three leading figures from the leather industry. We've got Mr. Satish Damle with us, who has been a leading industry consultant. He's worked with several tanneries and leather manufacturers, good leather product manufacturers and designers, and he shares a lot of experience in terms of manufacturing, the chemical processes, the dyeing and designing and so on. So we would like to hear some of his experiences. Satish is also going to moderate the session's conversation with our two other speakers, who are Dr. Kreisner and Dr. Buddhadev Chattopadhyay. So Dr. Kreisner has been the former head of global research and application in product safety at TFL Leather Technique Germany, which is a leading company industry in this sector. And our third speaker is Dr. Buddhadev Chattopadhyay, whom we all know as the former principal of the Government College of Engineering and Leather Technology from Calcutta. So we've got a very strong expert panel today to discuss this issue. So we'll have a discussion for 60 to 70 minutes, followed by 15-20 minutes of interaction. We want to see some good interactive session at the end of the 1 hour that we have left aside for the speaking part of it. And before I invite Mr. Satish to start the session, I would like to request everybody to keep their devices on mute. And if you have any questions, you may type them in the chat box and we will keep a note of it. So over to you, Satish.
Thank you, Vikram, and good afternoon from India to everybody, wherever my friends are. Jürgen, good morning to you. Buddha, good afternoon to you. Sustainability means what? Vikram, if you could put my presentation on.
Yes. So just give me a minute. Maybe you can just continue.
Yeah. All right. Leather per se, from the start itself, is a sustainable business, because if we don't process the hides and skins, which are a subsequent product of the meat industry, then you can imagine what will be the material which will go into the landfill and will cause even more havoc. So leather in itself is a sustainable business. Okay, over a period of time, especially people in India and some other part of the world have had bad publicity, and they have been a bit irresponsible treating their waste. But over last few years, a lot of belt tightening has happened, and people are moving towards I will not call sustainability, but yes, they are now showing respectable concern for the environment. So this is sustainability in the leather industry is what we are talking today. Let me just define what is sustainability means. Next, please. It means different things to different people, but in nutshell, we can sum it up as meeting the needs of today's generations without compromising the ability of the future generations to meet their needs. And in simple language, this is what sustainability means. Let us get into a little specifics of it. Who all should be connected in the sustainability management that we are going to talk about is the vendor, the material, production methods, of course, not only the how you produce the leather, but what machinery you use, what drums you use, what equipment do you use, how much water do you use, how much power do you use, do you have plans to successfully go ahead and reduce the water consumption. Then we must look at the hiring options, our business decisions, the CSR, carbon offsetting, and compensate the environment impact, simple thing like planting trees. Next.
Yes, John.
So the ways to be sustainable is to avoid waste, improve the material efficiency, control hazardous inputs, sometimes avoid hazardous inputs, maximize the resources, produce, in short, produce more out of less, use renewable energy, which leather industry, especially in India, hasn't really exploited, which they should. Designed to be recycled or recycling, water, or even the products. A good startup could be to collect the ladies' handbags back and produce smaller products. Designed to degrade, something which is very close to my heart is the wet white or chrome-free leathers, which can be easy to degrade and still remain cost efficient and make profits, make money for the shareholders. Next. Leather making is a chemical process. We must look at process optimization. It goes through a lot of chemical reactions, remove unwanted proteins, hair, fat, etc. is removed mechanically as well as chemically, followed by retanning, coloring, and finishing to get whatever fashionable leathers that we want, be it for garment, be it for shoes, be it for upholstery, furniture upholstery or automotive upholstery. Then have a proper chemical selection and optimal usage, machinery upgradation and selection, especially drums and auto sprayers and roller coaters, better water management and wastewater management. Conveniently forgotten is the solid waste management, which we must seriously look at because that can be a profit center in itself. Let us look at the chemistry today from two eminent experts, and I have been lucky to have worked with both of them. Jürgen was my immediate response point at TFL, and we have worked together for almost 12-15 years. Leather making itself is recycling. 7.3 million tons of raw hides and skins which are processed today would otherwise get into landfill. Leather is beautiful, everlasting, and naturally elegant, ages and becomes more beautiful. It's a byproduct of the animal fed and reared for farming and meat producing industries. It actually a lot of noise has been made that it uses a lot of water and needs to control it, but actually it uses 10% by weight um, of the total water consumed by the industry. Uh, and leather is also only 10% by weight of the animal that is slaughtered for meat industry. So it is important to note that in the last few years, the water consumption, which used to be 30 liters per kg of hide process, is now brought down to 10 in some developed countries and is hovering around 18 to 20 in India, which can easily be brought down to 10 by selecting proper equipment. So best way is to use less water. There is a recent beads which are being launched, which can be tried to reduce the water consumption as well. Next. So today we will first hear Dr. Buddhadev Chattopadhyay, previously the principal of School of Leather Technology in Calcutta. He has done MTech Leather and PhD in Chemical Engineering, recently recognized by the Leather Technologists Association for his lifetime contribution in the leather sector. I now invite Dr. Buddhadev Chattopadhyay to start his presentation, please.
Thank you, Swatis. And very good afternoon and good morning, wherever it is applicable to all the participants. Dr. Krishna, Vikram, and my fair ladies. Um, Today we are going to talk about something about the green chemistry. That's my subject of speaking. As introduced by Satish, that it covers a lot many areas. What is meant by sustainability is clearly defined, that we are not allowed to consume everything. We have to leave the resources, whatever we are receiving now, natural resources, with the same quantity and the quality to our next generation. In that case, when we die, our pictures will be hung in the wall. Otherwise, they will not hang our pictures if we consume everything. So that is what is called about the sustainability, and that we understand. Yes, there are a lot of many different areas and different factors. We would look into that, and we will see that how the concepts has developed into the production of a green chemistry. The green chemistry is not a specialized branch of chemistry like inorganic, organic, coordination chemistry, photochemistry, nuclear chemistry, etc. Green chemistry is rather a concern, rather a responsibility for all chemists and chemical engineering engineers. Whatever they do, they have to make it green. Green implies not the color. Green implies that the eco-sustainability. Green is the color of the plants. If we look from the outside the space, we look at the art as a mosaic of green and blue. Blue represents the water, and green represents the plant kingdom. So that's what we had to look into the nature and the concept developed later on. We'll see that how does it impact in the manufacturing of leather and the leather industry. When you talk about the leather industry, it's a big set because we take into consideration of rawhide as a one area, then tannery is another area, footwear manufacturing, leather goods manufacturing, then your leather garments manufacturing, gloves manufacturing. These are all different subsets of the big set of leather industry. I am focusing on the tannery because being a leather technologist, Our purpose is to produce from the hides and skins which are putrescible in nature to convert it into a value-added product of leather, which can be used for various different kinds of uses like bag or footwear or belts. Even the industrial applications are also there. So we manufacture them according to the physical and chemical properties that of the product that is needed, that is wanted by the buyer. So, and that is our whole objective. And there are a lot of many chemicals, process and treatments are available. At least 40 different chemical unit operations are needed for manufacturing leather, of which maybe besides these 40 chemical operations, unit operations, there are maybe at least 20 to 25 mechanical operations, and all of them are important. We can destroy leather at any place. So that's why we said always said that the leather needs a mother's care. We have to handle it in a proper manner. We have to nourish it in a proper manner, and there lies a big challenge. And the challenge is not only in the case of manufacturing, but also in this case of I would say um, judicial use and the judicial use and judicial component. Let me share my screen. Well, that's the green chemistry in leather making. And when I say about the leather making, I'm really meaning the leather making. That means the tannery as such. And some of the major strikes in this kind of concept that came in historically is a modern environmental development, environmental movement, started from Rachel Carson's book Silent Spring. Then there's a green chemistry movement. Then signing the Montreal Protocol of CFC phasing out as a refrigerant. The first concept of atom economy in science was boosted by B.H. Trost. Total synthesis of natural product like B12 is another milestone. Then E factor in specialties is another milestone to reach to the green chemistry concept as we see today. Now, what is it meant by the term ecology? When you say that ecologically sustainable, when you say that it must be ecologically compatible, eco-friendly, and all these terms, what is means by ecology? Ecology came from the Greek word, two words, oikos and logos. That means household and study. That means study of the home. But this home is not confined within the four walls where we live. This home has a bigger implications. That means the homes means in fact the entire area surroundings where we are living, and there are interconnection with that. And you can see that the object of this is to study the structure and the function of the nature, distribution and abundance of the chemical of the different animals. Why is it that the zebra and giraffe is available only in Africa and not in other Asian countries as a natural habitat? The interaction that determines the distribution and abundance of different organisms are among the various aspects of ecological concern. Now, if why is it that important to us? Why is it that it must be concerned about it, and where from the concept of green chemistry came up? Because in any ecosystem, the main principal component of the energy is the solar energy, and that is maximum utilized by the producers, that is the green plants. They have lowest consumes, and the maximum amount of solar energy converted to a chemical energy in the process of in the chlorophyll to produce the carbohydrates and the much needed oxygen. The death of the producers goes to the decomposter, and this primary producer, that the green plants are being consumed by the primary consumers, that is the herbivores who are grown on the plants. And then the herbivores goes to the secondary consumer, that is the carnivores, and their deaths and the waste products are again goes to the decomposer. So you can see that the flow of energy and mass and energy are flows in a sort of a stratum, in sort of different strata from one organism to the another organism through a channel, through a chain, which we call as a food chain. And when it is in a complex, lot many food chains are interjunction together, then we call it as a food web. So that's the kind of a thing from where the mass and energy are transferred. This mass and energy are in fact the two vital component of the entire universe, and we are concerned about that how this is going to be converted and how this is going to be conserved, how it is going to be preserved, and how it is going to be handed over from one generation to another generation. We have to understand that we cannot live, no species can live as a single species in the entire in the earth, in the atmosphere. We have to make a balance with every species that is available, whether it is a pathogenic or non-pathogenic, whether it is a corona or it is a bacillus leprae. We have to live with them. We have to adjust with them peacefully. Now, that's the kind of a thing, the food chain that I was talking about. You can see at the left hand blue shaded area that the zooplankton, the phytoplanktons are there in a lesser number, in a more number. Then there comes to a zooplankton who eats the phytoplankton and thereby changes the mass and energy. The zooplanktons are eaten by the small fish. The small fish again grows to a big fish, and there are also herrings and the other birds which can take out the fish and they can thrive on, live on. So you can see there is a connection. There is a connection between the energy and the mass consumption between one organism to the another organism, and everything is very very important in order to sustain the balance. Our tannery operation or any other operation in the chemical industry, or any other industry is aiming should aim to such that we do not disturb this equilibrium. We don't disturb these balancing factors, and that is the main concern of the green chemistry. Of course, where do we stand as a human? We eat almost everything, and therefore human cannot be assigned to any particular trophic level in the food chain. But human is to be said as a human is in a food web. It's a kind of interjunction of different food chains, small food chains, and we live at the food web. So any kind of things mass that is being transferred from one species to another species, ultimately it reaches to the human. That's why it is important not only for the animals, not only for the biotic or the abiotic component, but also for our own sustenance. This is the most important part, that for our own sustenance this is very important, otherwise we are going to be eliminated. Look at the how these toxic elements can be magnified. I am giving you an example of the famous Manamata disease that happened in Japan due to the absorption of mercury. And the mercury was let out from a factory. It went on as a effluent into the pond. The fish is to take it, the phytoplankton is to take it, phytoplankton for to zooplankton eats the phytoplankton, the mercury goes to phytoplankton. Phytoplankton are eaten by the fish, and the fish also accumulates the mercury. Finally, it goes to human, and human accumulates the mercury. And we have noticed that in the every steps, the concentration of mercury grows up and up. That is what it is called biologically magnified. And as a result, the whole Manamata village was affected by the mercury poisoning. That is what the importance of food web is. Well, we know that there are essential elements which are needed for any life to sustain, and there are also non-essential elements. There are also certain amount of micronutrients that are needed every day, and that is mostly fulfilled by our dietary intake. Every organism exchange the matter or the mass through the vehicle, which is called the environment. So the quality of the vehicle, quality of the transporter is also very important to transfer the matter or the energy. And there is a relationship between the wanted or the essential elements and non-essential elements. And you can see here in this curve that either the low input of the essential or the higher input of the essentials are both are bad. Mostly it is important to have a balance between them, just to have an optimal input. Either low input of essential elements is destructive for the health, or the very high input of the essential elements are also very destructive. The red curve shows the essential elements, while the green one is the non-essential elements. And you can see that, okay, if you do not have any input of non-essential element, nothing happens. But if you have a middle amount where it is corresponding to deficiency of the essential, it is going to be a poisoning for non-essential, and still higher it can go for lethal dose, that is the death. So that's what the relationship. Another beautiful relationship you can see in this pyramid. You can see as we go from the higher trophic level and levels, see the primary producers at the bottom of the pyramid. Their mass, total mass and numbers are much more as compared to the secondary consumer, that is the herbivore. Their number is less and the mass is also less. And then it goes to the top to the carnivore. You can see their number is also reduced and the mass is also total mass is also biomass is also less. So that's the kind of a pyramidal structure that defines the mass and the energy relationship in the food chain. Now we are coming about the tannery and how does it affect to the ecological system of our. This has been the work of Government College of Engineering and Leather Technology over the past 25 years in the Calcutta wetland ecosystem. And our team of researchers worked days and nights over the different seasons to see what is the impact of the composite tannery effluent on the environment. Now, the Calcutta has a unique position because neither the municipal sewerage nor the industrial tannery at the time of 150 years ago, since the tanning operations are going on. About say for 20 years back also, neither the tannery composite tannery effluent nor the municipal sewerage were treated, but they were passed on through a flat kind of a canal known as a storm weather flow canal SWF, which is 40 kilometer long, and this is to traverse the 40 kilometers, exposing themselves to different weather conditions, rain, sunlights, and then all these things, kinds of things, and then they are passing on to 40 kilometers very slowly because it was a more nearly a flat with a very low inclination of the canal, mud canal, and they used to flow down there, and therefore, and there are also a lot of human intervention in that canal. The water was used as irrigation purpose, so therefore there are toxic elements. If there is any toxic elements of the tannery that are going to be subjected to the irrigation, these wastewater are used for pisciculture. About 186 fisheries are there, and the fish are wastewater fed fish. So therefore, there are a possibility that they can imbibe some of the toxic element. So our benign approach was first in 1998 we thought that if these are said to be toxic, let us try to investigate what happens, how the nature negotiates with those toxic elements. If there is a toxic, if they are toxic, then the level of toxicity or the symptom of toxicity must be visible in the biotic kingdom or the abiotic kingdom. So we made an extensive study, and the study is still going on, 25 years long. And you can see that we have used most of the ultra modern instruments and even the atomic physical nuclear physical instruments like atomic force microscopy, like EDAX, like PIXI, proton induced X-ray emission. All this technology has been used to find out what are the finer tricks of the nature. I'm not going to discuss in that elaborately because that is this audience I believe is not specifically focused to leather science. They are a mix of audience, therefore we'll go somewhat we try to level out to certain extent. Now, as Satish has said, the typical mass balance was at the time, long back, 20, 25 years back, the 1000 kg of heights requires 30 cubic meter of water plus 247 kilogram of chemicals. And with this 1000 kg of heights, look at that, producing 150 kg of leather, 150 kg of splits, another byproduct of leather, but used as a leather or leather substitutes. 700 kg of solid waste, which Satish said are mostly ignored, but that cannot be ignored according to the mass balance. And entire 30 cubic meter of water is converted into 30 cubic meter of effluent. Of course, as he has mentioned, that 30 liters per kg is not the input now. Now the ratio has come down to 18 to 20, something like that, and we can further improve in this area. 30 cubic meter of effluent contains 400 kg of total solids. It's a high, very high total dissolved solid content. 400 kg of total solids are containing in 30 cubic meter of effluent. So you can understand that the possibility. Now let us try to look into these very, very important international aspects that I am afraid to touch upon, but I am confident. The common perceptions are tanneries are most polluting. So this also mentioned very benignly that it is not that, but I say very strongly that no adverse effect on ecosystem was found by our team for the last 25 years. No adverse effect on ecosystem. Chromium is a buzzword, and Sothish also admits it. He said that to go for white leather because chrome is not that important biodegradable. I said that chrome says is suspected carcinogen, suspected, not yet proved. But chrome 3 as an essential element for mammals, all mammals. Now, the chrome 6 today, the chrome 6 has been called as a suspect as an allergen, and rate of occurrence of chromium allergy for in human skin contamination is 4 in 1 lakh. At least 20 times more people suffers in United States of America alone for pollen allergy. If we ban chromium 6 for skin allergy, are we going to ban the pollens, flowers, fruits? Are we going to call back the silent spring? Chromium 3 is an essential element for lipid and carbohydrate mechanism metabolism. An EPA accepted standard is 1 milligram per kg of body weight should be the dietary intake of chromium 3. You will find even today a very common B complex like Bicosul capsule. You will see that there are chromium 3 in it. For the protein supplement given to the diabetic patient, if you look into the composition, you will find chromium 3. Okay, chromium 3 can be taken only through the dietary intake, either in the form of natural or in the form of a drug. Choice is yours. There has been a lot of controversy about the free formaldehyde in leather is a carcinogen. That was the most common perception. Then my question is, what about the free formaldehyde in apple, tomato, or even the smoke? Whether the formaldehyde is produced biologically, biosynthetically, or whether the formaldehyde is produced chemically in a chemical manufacturing company, formaldehyde is the same. It has the same structure, same property. And the biological system synthesizes the formaldehyde to protect their fruits. When we take apple, when we take tomato, we are consuming them directly. But if the free formaldehyde is there in the leather, that is can be digested, that cannot be digested. It can only come through skin contamination. So that's a kind of a dichotomy. There is a saying that the leather takes a much long time for biodegradation. So this is also concerned about that. Leather takes at least 75 years to decompose. You know how much nappy takes? 150 years. Twice that. Can you see a world? Can you imagine a world without a nappy? So, I am fully convinced that the tanners has been painted with a thicker brush than they deserve. But there is no reasons for either any complacency because I believe that even the best can be improved. But we are not that bad as has been painted by the artificial leather, uh, the coterie or the media or beta or vegan leathers or something like that. We are not that bad. Coming to the point, if you look at the global water resources, and by the way, water is the only available material, biological material in the earth itself, in the whole of the Milky Way where we are standing now. And water is an essential element. Without water, no life can survive, no cell can survive. And that is the estimate of total water available in the earth. If you look into that, you will see that much of them are not usable because Earth's surface water, which constitutes about 13 billion, is most of them are the ocean water or the sea water. Only Earth's interior, which are very small as compared to them, are very small. So if every kg of leather requires about 30 liter of fresh groundwater, or maybe 18 to 20 now, who is going to replenish? Who is going to replenish? Whether the water is drawn from the underground for the tanning purpose or drawn for the municipal purpose, drinking water purpose, who is going to replenish? If you look, because of the great urbanization, there is hardly any soil. Everything has been concrete or asphalt coated, and the wetlands are being grabbed. There are hardly any wetlands or wetlands reservoirs. And if you look into the interior of the earth, if you have a building, if you make a piling, if you dig a soil, you will see then even after 1 or 2 feet, 1 meter or 3 feet distance, you will find a layer of plastics which is preventing water to percolate in one hand, and on the other hand, which is preventing soil to respirate. Where we are heading to? So there are the challenges that we can see is the scarcity of the technical and the fiscal resources, the weak regulatory institutional framework like legislative, judicial, pollution control, independent data collectors, watchdog books, etc., bodies, etc., less prevalent stimulus package, weak R&D capabilities, and more favorable public sentiment for the economic development relegating the environmental issues. But
Dr.
fortunately,
Prabhadev,
sir,
can I intervene here for a minute?
yes,
So, in the interest of time, can I request you to
okay,
go to the specifics of
okay.
the sustainability interventions that
I,
the leather industry can adopt?
yeah, yeah,
In fact, there are some questions also in that regard. So, I would request you to focus on that with very specific suggestions if you may have.
okay, fine. Uh, we need to address, we need to capacity expansion, we need to develop technology, we need to make a higher global market accesses, etc. And if you look at the tanning levels, you can see that the hides and skins, it can be used as a less salt or salt less. Byproduct utilization is the important area. Gelatin, pet food, leather products, chrome pickle, and there are recycling. It can be done for chrome liquor, pickle liquor, or the deherring. But we can look for the technology for high exhaustion enzymatic process and reuse the salt and solid waste from solid waste to products, and water reuses can be done, and this has been given in this particular chapter. There are a dozen of green mantras for making it green: minimize waste, atom economy, less hazardous synthesis, safer chemicals. At least those you can see the aesthetics can be done easily by the tanneries. Out of the dozen, at least 9 can be done in the tanneries itself. Economic implications are there. You can see here that even if we try to reduce the wastewater quantity by 8.5% and chromium divert reduction can be done by 55% only by, recycling. 25% of the dye can be recycled, and that gives us a investment that the investment can be given us back as a savings. Now, if we look at the chromium and their exhaustion pattern, you can see that the conventional is using only 34% in the grain leather, and high exhaustion as compared to that 45%, chrome retiring 40%, etc. Now, I would say, what is the golden rules for the green chemistry? Reduction of in-plant pollution control load rather than efficient end-of-pipe treatment of waste. Optimize atom economy, that all chemicals needed to make leather should be incorporated in it. Look for the higher exhaustion either by exhaustion aids or by altering applications. Avoid generation of hazardous substances in situ or outside, because risk is a function of both hazard and exposure. Design and use chemicals of lower toxicity. See the toxicological profile, ecotoxicological profile of all auxiliaries. Minimize use of auxiliary substances that do not form a part of a leather. Avoid unnecessary loading and replace solvent-based system by aqueous-based system. Minimize energy consumption and minimize water consumption. Water do cost because we are depleting groundwater resources. So look at these things, that only 15% of hide mass is used as leather and 15% as fleet, 70% precious biomaterial, protein biomaterial, of which most of the important components are collagen are wasted. And today's drainage can be tomorrow's treasure trove. You are from Germany, you know that you go to any European country, you will not find a shampoo or a bathing soap or which doesn't contain collagen. And this collagen, so all this comes from the waste collagens for that kind of a thing. And we can show you a higher possibility. What is that Schumacher's mantra? Schumacher, the great component of small is beautiful. He said that wise use of knowledge is that which leads to well-being of the individual and the society. Misuse of science and technology is most poignant example of danger when increase of knowledge is out accompanied by the increase of wisdom, decreased consumption. Now, when you talk about the byproduct potential, you can see per kg of collagen what could be the recovery. When you make a hydrolyzed, it is only €8. When you make a good leather of Italian tie, we can make per kg of collagen, not per kg of leather. Per kg of collagen, €120 maximum. But if we make, for example, soluble collagen air grade, it's €200,000. Injectable collagen, which is a must for any kind of a plastic surgery, is €500,000. So there lies the fortune opportunities if we can make it, if we can develop those things instead of draining it out, if we can develop or recover something like, through this process or maybe through tissue culture, then that could be a boon to the humanity. East Calcutta, pre-monsoon, post-monsoon, carbon dioxide footprint we have evaluated. You can see that the difference in the seasonal differences. So that's what Rachel Carson said. We don't want to live in the world where there will be no birds will be singing, no sound will be heard. It's only we are silent and silent and silent. Thank you very much. Thanks to all of you. Namaskar.
Satish, you're on mute.
Thank you, Dr. Buddhadev, and a lot of questions are coming your way, which we will answer at the end of Dr. Krishna's presentation.
Yeah.
Now I invite Jürgen Krishna to start his presentation, please. Jürgen?
Yes. Can I open my presentation here?
Yes, you can.
Yes.
Okay. Can you see?
Yeah, please go on.
Okay, welcome again. Good afternoon to everybody. I'm speaking, I'm in Germany right now, and it's lunchtime, but I'm happy to spend the time instead of lunch for something very important, which is sustainable chemistry in leather making. And as Dr. Buddhadev already mentioned, and also Satish, it's a key issue in leather manufacture now. And we have faced in the past years in the leather industry many challenges on this. It's very clear, and I don't want to repeat so much what was already mentioned. We cannot continue using fossil-based resources as we did in the past. This is very clear. We have to use more renewable sources, be it solar, wind, hydro, geothermic, biomass, waste. Also, waste is a resource. And we have to develop products whose production consumes less energy and raw materials and has a low environmental impact. If it comes to chemicals, this is a big challenge. We have to develop products which have a good end of life. A good end of life is key. And if we look at leather, it's an essential part of leather making of the future. And we have to develop products which consumers can and more likely will use for a longer time. If you have a precious product, you are more likely to use it for a longer time if you like the product. And if it was a little bit more costly, you are less likely to throw it away, after one season. Now, definition of sustainability we heard about. We have to look at the specific sustainability parameters of leather making. And if we talk about leather, from a consumer's perspective, it's a natural product. It's perceived as a natural product by many consumers. And however, despite a solid global production of beef and meats, and the related availability of hides, the leather consumption took a significant dip in the past years. That means we have an increase in global production of beef and meats, but we have a dip in the production of leather. And this decrease is not caused only by vegetarians or vegans, but mainly by consumers who are still eating meat. And this is the key question, in my opinion, and we have to ask ourselves, why is this happening? And the critical issues related to leather are very clear. We have the sensitivity with regards to animals, the animal welfare and well-being. Then we talk about the conditions in animal production, industrial production of animals, and meats. There are a lot of media reports on this, at least in the Western Hemisphere, and rising concern of consumers on that. We have media reports on working conditions in tanneries, pollution of toxic substances, the large consumption of resources used in leather making, and of course the emissions from greenhouse gases from cattle breeding. And if we look at the carbon footprint calculation, there is a large carbon footprint coming from animal breeding. And a certain part has been allocated, of course, not only to the meat, but to also the other products of the animal. Then we have the rise of synthetic leather substitutes. They are easy to process and new materials come to the market, which improve continuously in performance and also allow many designs. Then the Generation Z does not know leather well enough. This is another issue. There is a competition with new products, and if you look in big cities here, probably 70–80% of the shoes people wear are plastic shoes, and leather is becoming more a niche product, and particularly the younger generation has a different attitude to this product than probably the older generation. Nevertheless, why should consumers buy leather? Because it's potential, it's a natural product. It can be a natural product if we do things right, because it's based on a valuable renewable biomass. Leather is very valuable and durable. That means it is long-lasting, and it ages with beauty. Leather with good quality, if it ages, it becomes more beautiful. This is in contrast to many synthetic polymer-based products. Leather can convey comfort, for instance, for shoes, because of the breathing possibilities, and it is able to please our senses. There's the feel of leather, the smell. So in a world of flat screens, this is an important factor, actually, that we have to deal here, or we can deal with leather as a material which is pleasing our senses. However, if you look at leather manufacture, as already mentioned, numerous amount of chemical products are needed to make a natural product, and this is a conflict we have. So the criteria for sustainable leather manufacturers are on one side the hides and actually the animals, where they come from, the origin, do they have good husbandry, what are the slaughter conditions, transport, and so on. This is very important, and in future we will have to give proof of, the hide, where it comes from, because tracking of materials will become more and more important. And this is already part of the various audits done in the leather industry. Chemicals, of course, what type of chemicals and how much is being used? Are they ecotoxicity? Are they based on renewable materials? Then safe chemical management, working conditions in tanneries, because they can be seen as a chemical operations, because they work with chemicals. Water consumption, you already mentioned. Energies, are they renewable? How much is used? Emissions, liquid wastewater and gaseous emissions. This is very important in leather making. Also the smell in tanneries, yeah, to contain this one. All byproducts, yeah, it's critical. They are valuable resources. And most important, end of life. Reuse, can we reuse less, can we recycle? How is it with, with biodegradability, compostability? And if we say leather is, basically a recycling industry, this is only partially true, because actually we make leather and we have to ask ourselves, we use the hides, yes, but we make out of the hides leather, and the question is, what happens? What is the end of life of leather? So leather is an alternative to plastics. And if we look here, it can be very easy. We have the hide as a renewable biomass. We make with chemicals, and I say with good chemicals, we make leather, which is biodegradable. The leather is grinded up into powders and goes back to agricultural gardening and goes into biomass. With this, plants are grown again, eaten by the animals. So this is the ideal recycle of the leather industry, and this is the potential marketing advantage leather does have. Chemicals play an important role. We come to this later. Yeah, of course, if we say leather has to be biodegradable, also the chemicals need to have a performance profile which is good as to biodegradability. Optionally, yes, renewable. The more renewable chemicals we have, the better, because also to this we come later. If we took a look at the carbon footprint of leather making and take out the contribution of the hide, which is very large, then the chemicals are the second largest contribution next to the hide of a leather manufacture. And that's why it's important to have a focus on the chemical products. Bio-based chemicals in leather manufacturers, we have various sources, vegetable oils, fats, then even CO2 can be turned into chemicals. We have polysaccharides, cellulose, sugar, starch. Of course, a huge amount of, or various amounts of vegetable tannins and lignin coming from wood, various trees. Then the proteins, either vegetable or animal-based, and biofermentation products like enzymes. These are all sources for resources for chemical modification to turn into a bio-based chemical product, which is usually biodegradable, has a lower carbon footprint, and advantageous ecotox profile, but not always. I will come to this a little bit later. The key is, and Dr. Budadeb already mentioned this, is the consumption. Yeah, and the consumption of a chemical product, but also human consumption eventually. But here's the consumption of the chemical product and the efficiency or efficacy of the chemical. That means, does the chemical end up in the hide where it should be or in the environment? So this is a very important factor to consider. If you look at the leather making process, we have two main parts. We have the wet part from the beaming, from the rawhide to bedding process, where the chemicals we use in this part all go into effluents. Yeah? And after bedding, we start to add chemicals which are meant to remain in leather. And this is a very important issue here to understand if we devise our strategy on modern leather making, and of course the chemicals we use. That means here the chemicals need to be biodegradable, of course, but also here the chemicals need to be biodegradable if we want to have biodegradable leather and good to the consumer. That means no emissions from toxic chemicals, the consumer eventually would see. If we look at the beam house operations, we are talking about wetting, dispersing, and degreasing properties used in the soaking, unhairing, deliming stage. And here, the industry already is using mainly fatty alcohol ethoxylates based on natural alcohols. This is a renewable source, or fatty alcohol ether sulfates as anionics. And APOs, that means nonylphenol based products, are almost out of the industry. And here actually the leather industry was far ahead of the textile industry, which still has issues with nonylphenol ethoxylates. So here, in many other cases, the leather chemicals are more advanced than often in textile. A new alternative, relatively new alternative, is the enzyme-assisted degreasing, where natural grease from the hide with enzymes like lipases active between 9 and 10 under the presence of calcium or magnesium will be turned in insoluble matter, and which can be skimmed off the floats, the processing floats. So this is a very economic, but also a very efficient and biological degreasing process. An important part is, of course, the unhairing of the skins and the hide. And here we still deal with sodium sulfide, which is the most hazardous chemical in leather manufacture because it is toxic if inhaled at high concentrations. And it's also water toxic. And replacing sulfide is a big issue, has been a big issue for chemical manufacturers and many institutes who do research on this topic. Enzymatic unhairing is possible, but has not made any success in the industry, a full success story in the industry, because we never reach complete unhairing, and sometimes leather quality is suffering. Oxidative unhairing is possible as well, and it's very eco-friendly. However, the leather quality achieved is not sufficient yet. And what the current status is an enzyme-assisted low sulfide unhairing, where the sulfide amount is greatly reduced by applying enzymes which are lipase proteases, and here we can achieve a 60% reduction. Most important here is that the residual sulfide, which is still present, is either oxidized in the process or outside the liming process or unhairing process, catalytically with oxygen or peroxides. Yeah, that at the end we have a sulfide-free effluent, and this is possible and should be state-of-the-art. Also, in order to save solids and COD, hair saving should be a must. Salts is a big issue, also in India, mainly in India, I think. And here the salt load comes from preservation. Fresh hide processing should be the goal, and because it just prevents assault. And if we do a short-term preservation, a biological short-term preservation at pH 3.8 to 4, we can get a couple days of preservation, and basically with almost no addition of salts and only some organic acids which are biodegradable. There are also glycols can be used to replace, but this is very costly. It has not made any success in the industry. The other step is the pickling salts. Here, the reverse tanning for thin skins is possible, but sometimes suffers high leather quality is suffering. Recycling of pickle and tanning float, if it's done in a controlled manner, it's very well. It's possible. And of course, the use of aromatic sulfones. However, here we are using chemical substances to replace salt. So this depends, on your effluent treatment, if you can digest the final wastewater in a proper way. But it's possible to replace salts with those aromatic sulfone products. Another big load comes from deliming ammonium salts. Here we have organic mono decarboxylic acids, which are fully biodegradable. They can be used together with CO2 gas in order to delime, or cyclic esters like propylene or ethylene carbonate, which are fully biodegradable. So ammonium can be reduced or eliminated. Very important are new drum designs where we can control under pH control add the chemicals in a very good manner. That means in a very controlled way, and safe chemicals. And here, this is a challenge for drum designs and machinery people. There's still a big room to make advancements. And that means if we do the addition in like a titration process, and not in a batch addition, here we can save a lot of substantial amount of chemicals. Chrome tanning is a big issue. It's the main tanning method still, and it's the most versatile and gives us the highest overall performance. The issue is with chromium-6. It has been mentioned, chromium-6 as a potential allergenic product, or as a carcinogenic product potentially. But it can be managed, and if we know how chromium-6 is formed, it can be avoided easily. However, if we talk about sustainable chemistry, chrome tanning is only sustainable if the 400,000 tons of chromium were used worldwide, and which are entering the environment via leather. If this leather is recovered again, or the chromium is recovered from the waste leather, that means we have to ask ourselves, what is the end of life of leather and what is the end of life of chrome? The chromium is not renewable, it's not biodegradable. We spread currently these 400,000 tons of chromium into the environment. If we don't recover, we disperse it, and it's there in low concentrations in the environment where it will not be recovered again. So this is, it's not the toxicity. This should not be a concern because we can manage it. It is the question of sustainability of chrome, which puts a big question mark behind this tanning method. If we come to chrome-free, the most common nowadays method is a modified glutaraldehyde method. This is a very efficient tanning method. Yes, glutaraldehyde is a hazardous product. It requires safe handling, but it can be handled safe. The reaction product is non-toxic because it is cross-linking collagen. And the modified products actually in form of acetals are even not toxic as such and have not negative labeling as a chemical product. This glutaraldehyde pre-tanned or tanned leather can be used with zirconium, small amount of zirconium salts into tanning or retanning to add some cationic charge to have a good exhaustion later in the retanning, because the disadvantage of glutaraldehyde tanning from a cost point of view can be the higher amounts of syntans or vegetable tanning products used in the retanning. And these are all aromatic products, and float recycling is a must because these aromatic products should be in the leather and as little as possible in the waste. Then we have the triazine-based products. This is a very complicated aromatic structure. Here the chlorine is reacting with the collagen and cross-linking. Pickling salts can be reduced. The quality consistency is not given, unfortunately, always. And triazine-based products are also used in the industry, but not by far less than glutaldehyde. Then we have the olive tanning. These are natural aldehydes extracted from olive trees. There's this company, Wet Green, in Germany, who is promoting this. It's a natural aldehyde. The tanning method is costly. However, since it's gained from olive trees, it follows the cradle-to-cradle principle and has, from this point of view, a very ecological profile. However, here it's a cost and it's an aldehyde, and this is a good example, and studies showed that this natural aldehyde actually has a higher mutagenic potential than glutaldehyde, which has none. So this tells us that natural products are not necessarily always, from a tox profile, better than synthetic ones. Vegetable tanning, yes, of course, it's time for vegetable tanning, yeah, but large quantities are needed. That's why the preferred way is to co-use the vegetable tanning, for instance, as retanning of glutaldehyde type tanning, yeah, or in combination with aromatic synthanins, which are close from chemical character to the veg tannins. Yes, veg tannins are not easy biodegradable. Yeah, that's good. So otherwise we would have no trees, yeah, if it would biodegrade so easily, because the veg tannins are coming from the bark of the trees. Similar characters we have with the synthetic synthanins. Yeah, however, they are fossil-based. We have to deal with residual formaldehyde, phenol, naphthalene. It all can be managed. Yeah, synthanins are high fastness products. That means mostly used also for automotive tanning, automotive leather tanning, where high performance is required. Also synthanins, because they are similar in structure. They are polyaromatics, not easily biodegradable. And here we have to do a float recycling, a monitored float recycling, yeah, and to reduce the amount of effluent, and then treat this effluent in a proper way. Dyes are complex structures, yeah. There are dyes which have also CMR properties, carcinogenic or mutagenic. And this has been identified during testing for REACH. So this is a positive side effect, that we know now much better the dyes we have for use. From a sustainability point of view, they are all synthetics right now. It's important, no forbidden amines, no forbidden metals like lead or mercury and so on. And of course, and this will be an issue for the chemical manufacturer, that we have a clean manufacture of dye. Dye manufacturing can be very polluting. And here, the audits will go back from the tannery to the chemical industry in future, yeah, that they prove they do clean manufacturing here. There's an option for plant-based dyes, but this is a niche business. Some people, small companies started doing this. However, it is a huge opportunity for regional natural resources as a marketing tool. So why not? Yeah. This, at least, interesting for the future. Softening filling agents, here we use already natural oils as a renewable source. This is the main source here, sulfonated and sulfated oils, natural oils. Yeah, we have to protect those oils against chrom-6 formation, because they have unsaturated bonds, and antioxidants need to be added here. The goal here is we need to have a good uptake, otherwise the COD in the floats in the effluent will be too high. Then we have polymers. used in leather manufacture, polyacrylics, polyester, and modified polysaccharides as softening and filling and waterproofing agents. Here, the sustainability factor are the monomers based on renewable sources. Acrylic acid can, but still double the price, yeah. But this will change over time, and many derivatives as well. The polymers are mainly preferred in high fastness applications like automotive, where the natural products are probably not as light fast and not as good in aging. These are extreme applications for automotive leather. Then we have finishing oils. Here we can also use natural oils and waxes as an interesting alternative to synthetic coating polymers. Yeah. And together with vegetable tanned or retanned leather, this oiled leather develop fantastic physical mechanical properties. You can have a very good abrasion. You can take a sharp knife and rub it on those leathers. It's impossible to destroy it. A fantastic product, oiled off vegetable or retanned leather. And these leathers also have a very nice, pleasing finishing aspects. Some final considerations. All substances, either natural or synthetic, bear a potential risk and need to be handled properly. A risk assessment of a chemical product should be based not only on straight toxicity and classification. Most important is that it's not an CMR product, carcinogenic, mutagenic, reprotoxic, that it's not persistent in the environment and bioaccumulative, that it allows safe handling for the workers in the tannery and a safe end of life. That means biodegradability. Yeah. That has a positive impact on reuse and recyclability. Renewable products are not necessarily better biodegradable than synthetic ones. Absolutely no. And from a carbon footprint point of view, renewable products depend. The carbon footprint depends very much on the chemical modification done. Yeah, and sometimes can even be higher than synthetic ones. And in our company, we did such a polymer, and we were very polysaccharide, and thought, okay, do have a very favorable carbon footprint. And then we did the calculation by a third-party institute, and it did not show an advantage. So this is something to learn. However, this is a calculation of the carbon footprint. Maybe the fossil oil need to be pre-charged already with a defined kilogram amount of CO2, question mark. Yeah. Then I mentioned already future advances in machinery is very important to reduce emissions. Batch versus single hide treatment, for instance. Yeah. If we find better machinery, better ways to leave the chemicals in the hide and not in the effluent, yeah, this is possible. I'm deeply convinced of this, and there are also ideas on this. However, the leather industry is a small industry. Investments need to be made, and somebody needs to go forward. I hope so. And the good thing is we have audits in the tanneries and chemical suppliers. Yeah. We are already audited by high standards. Yeah, the chemical suppliers, for instance, TFL, I worked for, ZDHC program, yeah, where you go through a very tough audit, yeah, for chemical sustainability. And the leather working group, for instance, for tannery, yeah, on the tannery side, where they already look at the origin of the hides, yeah, the conditions in the tanneries, effluent treatment, and so forth. So if we do things right, we have, with leather, the ultimate sustainable product. Thank you very much.
Thank you, Dr. Krishna. I think that was very informative. Although we have kind of running too late, but probably we can spend another 10-15 minutes in looking at some of the questions that have been posted here. Satish, do you want to take any of those questions, or should I?
There is a question by Onkar Nath. Says biodegradability, is it a part of green chemistry?
Can you repeat the question, Satish?
Onkar Nath is asking whether biodegradability is part of green chemistry.
Indirectly, yes.
Yes, it is. It should be part, and it should be part of leather for sure. Otherwise, leather is not a natural product.
Okay.
However, one important thing, biodegradability. The important thing is, for instance, if we have a leather coated with polymers, yeah, and there's this little thin layer of polymer coating finishing on the leather, which is polyurethane or polyacrylics, yeah. Of course, this part, if we grind up leather, will not biodegrade as quickly as the collagen part. However, it will biodegrade in non-hazardous substances because we know the structure of the polymers and we know where it will degrade as a polymer. So the important thing is that the degradation products are not hazardous. So if we would have a biodegradation of leather, it's important that the biodegradation of the chemicals in the leather, and by mass percentage, it's only 5–6%. Yeah, the rest is collagen and salt. Yeah, that this biodegradation does not end up in persistent biotoxic products. And with polymers, it's not an issue. With polyurethanes, polyacrylics, it's not an issue. They will degrade. It takes longer, maybe 70, 80, 100 years. Yeah, but the end product, yeah, if we bring out this leather powder in the soil and gardening, yeah, these are inert particles, these small coating particles, yeah, and it will not impair plant life because it's like a stone. It's an inert particle, and that's why we should not be concerned about this small amount of polymers, for instance, yeah, which are not easily biodegradable from a timing point of view. And the same applies for veg tannins. They are also not easily biodegradable. However, they go back to nature at the end.
Somebody asked, Chrome, does it become Chrome 6 becomes Chrome 3 in the environment or not?
Chrome 6 to convert into Chrome 3 in the environment.
Naturally in the environment.
For conversion of Chrome 6 to Chrome 3 requires certain chemical conditions. For example, it must be acidic environment. And secondly, there must be a organic, reducing agents. If these two are normally not present in the environment, particularly in the water of the kind of a discharge that we are discharging, a composite Tannery effluent contains a pH about 8 to 8.5. So it is not an acidic, though there are a lot of organic reducing agents in the composite Tannery effluent, but the chance of auto reduction of Chrome 6 to Chrome 3 is much less as compared to the reverse.
I think it is always the Chrome 3 which becomes Chrome 6.
Yeah, that's right. That's right. That's right. Because of the oxidation.
If the environment is acidic, then it is already bad.
Yeah, right too. Right, you are.
The risk is very low. However, the Chrome 6 issue is out. And there is a certain perception in the public opinion, and this cannot be easily reversed. Yeah. And however, we are able to manage the chromium-6. That's not a problem.
That's not
And
a problem.
also the chromium-6 is not a problem. It's in the environment because we do not have these acidic conditions in the usually in the environment.
Exactly.
We know this. The issue again is chrome tanning a sustainable tannage? Chromium is not renewable. And if we are not recovering the chromium out of the leather, it's not a sustainable tannage by definition of sustainability. It's very clear. We have to be very clear. So it depends on the manufacturer, on the brand. Yeah, what is their policy eventually? Yeah, and it depends on us, the tanners. Yeah, what kind of marketing strategy we devise. Yeah, for selling a potentially sustainable product, which is called leather, which can be the ultimate sustainable product if we do our homework. Otherwise, if we try to compete with synthetics and so by cost and so, there's nothing to win. There's nothing to win. Synthetics have even a better carbon footprint than leather has if the calculation includes the hide, the contribution from the hide. Yeah? But since the animals are raised not for leather, some people still claim it's done, which is absolute stupid. Yeah, yeah. Then it's a co-product, the leather is a co-product, and we turn it into a highly sustainable material, which in an end article like shoes, belts, sofa leather, and so on, is able to replace, at least in this part, a fossil-based synthetic shoe or whatever product. So we have to do our homework. This is a very important thing. We cannot fight City Hall, you cannot fight City Hall. Certain things are already out, yeah, and to reverse this, yeah, it's very difficult. It's very difficult. A lot of initiatives are done leather naturally, where we have also white papers and good things, for information also with your young people, yeah, who can go to this website, leather naturally or mecha.com. And there's a lot of good information. Yes, it helps a lot, yeah. But still, we should think about leather as a natural product. This is what the initial perception of leather has been by the consumer, yeah. And now we learn over the many days, it's not so natural. We have so many chemicals, yeah, and probably we have too many chemicals, yeah. So probably we have to reduce not only the consumption by itself, by better application technologies, but also the number. We have already so many chemicals around, more than enough to use for leather. We don't need new chemicals. We need new ideas, and we need to do our homework from effluent and waste management and making the right decisions. That's all. We do not need new chemicals. Okay, if the new chemicals are renewable based, it's fine, great, yeah. That's of course very important for the future, but we do not need new molecules, new actives. We don't need. Yeah? We can make perfect leather already. Yeah.
Are casein-based finishes biodegradable?
Yes.
Is water-based PU biodegradable?
Yes, casein, of course, as a natural polymer is more easily biodegradable than polyurethanes, but polyurethanes are also biodegradable in good monomers. If you look at the polyurethane molecule, it will biodegrade. You can look on the web. It will biodegrade, however, not in 5 years, maybe in 70, 80 years, in those non-toxic substances. Yeah, and this is very important. Yeah, this is very important. Yeah? Also, veg tannins do not degrade easily. It takes a long time to.
But in the veg tannins, pyrogalols do degrade.
Say it again.
In the vegetable tannins, the pyrogalols do degrade.
Yes, of course, everything degrades, everything. Any veg tannin degrades. But in a
Takes a long time.
biological treatment plant, wastewater treatment plant, you have a retention time of 4 or 5 days. In 4 or 5 days, no vegetable tanning will fully biodegrade. And that's why we need a better application technology. Yeah, the initial veg tanning was a pit tanning, so floats were completely recycled. So we had very little effluence. However, it takes a long time. Yes, we need new methods with new machineries, a better application methods, or controlled recycling of the floats, of the returning floats, which can be done, which absolutely can be done.
So
I think the best thing would be for India to look at is for the slaughterhouses to get into the tanning business to avoid salt in the effluent.
Yes, that's already done in US.
Yes, but that is
big,
not
producers are all slaughterhouses or meat factories.
That is not happening in India. There were a couple of proposals made, but let us see what happens. Better equipment for water consumption saving and uptakes, and also proper process management is what is required.
Yeah, it's required that we do our homework. The technologies are there. The problem is the implementation and the training also of the tannery staff. We have we need much more education and training, also hands-on, and this is an issue in the knowledge training.
Okay.
So,
okay. People are asking whether we can have a copy of the two presentations. I think we will have that on YouTube soon. Is that right, Vikram?
Yes, we can share that copy. So we will get in touch with the attendees post this session.
All right.
I think in the interest of time, if there are no more questions, we can probably conclude the session. If I can probably request the three speakers to share very quickly, the concluding remarks in terms of some advice, in terms of how the leather industry businesses can take at least the initial steps to improve their processing methods and the processes itself.
May I say here something? I think a lot already in India, also in India, has been done. A lot of initiatives. We understand the issues. I think we more and more understand the issues, and we are on a good way. Yeah, but there are still issues around and which need to be improved. Yeah.
And we lack, as an Indian leather technologist, I feel Indian tanners, shoemakers lack communication with the masses as to what has been done and what will be done in the next 6 months, what will be done in the next year, and how will they reach whatever is the desired goal, is what is missing from the leather industry side in India. A better communication, better awareness of the consumer is not done in India.
Actually speaking, I think India has done a great deal of effort for reduction of tannery effluent and also at the same time eco-sustainability. What is needed for the tanneries to, as Dr. Krishner has already mentioned, that to train and to involve the people working in the tanning sector, how these things are to be handled, how these things are to be needed. And we use too many chemicals that may not be required at all. And so therefore a judicious application of technology and judicious selection of the material, maybe the chemicals which can do multitasking, that can replace one or two material. So what is needed is the overall concept and the overall appreciation of the particular product. And as I have already said, that as compared to leather as such, which takes 75 years to biodegrade, For biodegradability, in the biodegradability scale, 75 years is not much. But if you compare to the nappy that you are using for your kids, newborn kids or the kids of the very small children, it takes about 150 years. The third issue that strikes in my mind: why is the polymer developed? Why was the polymer developed? Polymer that we use in has a heart, the artificial track, GI track, a polymer that we use as a heart valve, artificial heart valve. They are not supposed to biodegrade. We developed polymers so that they cannot be biodegradable.
Yes, I mean, not easily biodegradable.
Not easily biodegradable.
Yeah.
So therefore, now we are going looking back that how to make manage, I to make both the two things both the two aims to merge together and to make it more biodegradable.
Yeah, but again, the large percentage is collagen of leather. Is collagen.
Obviously,
In
obviously.
percentage, it's only around 6% is chemicals. Yeah.
Yeah,
And the
yeah.
rest is salt and water and collagen. So
Obviously.
this polymers used in leather is mainly in the finishing. Yeah, in the finishing, polyurethanes or polyacrylics. End of life of those products. Yeah, as a small grinded particle, there's no problem. It's like a stone. Like a stone is inert in the soil. Yeah. So the question is, end of life, is it persistent? Is it bioaccumulative? Is it toxic to the environment? The degradation product.
As I have already said, that I strongly believe that the tanners has been painted with a thicker brush.
Okay. I think we've had a wonderful session and some good interaction as well. I would like to thank the three speakers, Dr. Krishner, Dr. Buddhadev, and Satish, for joining us today. We've had some good questions from the audience as well, and definitely once we continue this interaction offline with yourself and the attendees as well, we would be able to further this discussion to a much more advanced level. And if there is any feedback that the attendees want to leave for us, we've shared a link in the chat box. Please feel free to share your comments there. And if Juanita, would you want to say anything before we conclude the session?
Yes, I also want to thank our speakers for sharing with us their experience, and I learned a lot today about the leather industry, and thank you very much. And also want to thank everyone that is attending. If you have any ideas what we can do or any innovation, what we can do to further this conversation and how we can change the leather industry to make it more sustainable, just send me an email below. And let's have a conversation together. I work for the IC3 Innovation Hub in Frankfurt. So we're always working with startups, and we're also very keen to know what they are doing and how we can help them with their innovations. So in the chat below is my email. So let me know and we can have a short chat. So thank you everyone for attending. And I hope to see you soon in the next session. Next month, we are going to be talking about hydrogen. So that's also a very exciting topic.
Yes, that's going to be on the 30th of September, and we will be announcing the registrations soon.
Okay.
Thank you very much, and namaskar to all.
Thank you everyone for joining us.
Thank you. Bye
Thank
bye.
you.
Bye, Jorgen.
Bye.
Bye, Buddha.
Bye.
Take care.
Take care. Bye.